Thank you. Wow, this is exciting, right? So it's the second year. It's like it's a really packed house. So first of all, welcome everybody. So I'm Javier de Torre. I'm very, very glad to be here with you today. We're going to be talking about something that I think is quite popular, right? So I don't know how many times you've heard now these days AI, and we're probably going to be talking about it today. But before that, I want to go a little bit on the basics. So first of all, look around. We are at the Royal Geographical Society, and with sunny weather, which is very amazing, right? I think if you haven't explored the building, it's pretty nice. And also, don't miss the two sculptures, from Shackleton and Livingstone outside. They make for great pictures. So I always love it. I always recommend it. Second thing, I also want to give a big shout out to the sponsors, not only make it possible. They have booths here at the conference. I highly recommend to pass by during the coffee breaks, not only to know what they do, but they've been working over the last year a lot on adding more spatial capabilities to the products, and data providers adding new data. I think there's a lot to learn from the industry, and I think that's also a pretty important part of the conference. Big shout out to yesterday to everybody who participated on the workshops. I think we had some hiccups. We actually got lost on the way to lunch. Obviously, in a spatial conference had to happen. So no, but I think it was I really enjoyed them. There was talks around like a snowflake, a lot of spatial indexes, talking about H3. There was obviously about CARTO workflows and many different topics. I think it really now with boot camps, it's a fundamental part of the type of conference we want to provide, with the idea of not only getting to learn, but also in a hands-on environment. And I think that was great. It was also impressive to see some of people just coming for the workshops, and hopefully next year also to the conference. But yeah, thank you everybody who participated and who made them possible. Now, before talking about everything else, I want to tell you a bit about April in Spain. It was really hot. It was really, really hot. Actually, it was we got around 40 degrees towards the end of April, which, believe me, it is very extreme. We've never experimented something like this. It's around 10 degrees Celsius, above what it's normal. So a big heat wave, coming in April, which is very, very shocking. It got even in the New York Times, which you can consider it's a very global phenomenon. So it was definitely very important. And it's not only in Spain. Obviously, the rise of temperatures is happening everywhere. Droughts and the effects of climate change are these days more and more. We're all suffering them, and we're going to be suffering obviously for the years to come. And actually, even here, although it's actually sunny, last year in UK, there was a very big drought. And this was, you can see here even the building here in Hyde Park. And in summer, it also almost looked like Spain in April, right? So it was a very big thing, right? And this raise of temperatures, one of the things where, we are, we are feeling them more, having a bigger effects, is in cities. The so-called urban heat islands are essentially mean the effect that cities produce of actually increasing the temperatures even higher because of the lack of shadow, the lack of vegetation and all these things. And that's a big problem from a health perspective, but also from an economical perspective, from a social perspective. It produces all sorts of problems, as you can imagine, right? Now, one of the obvious ways, or most practical ways to fight this type of urban heat experience is to use trees. Trees really help to regulate temperature, not only because they provide shade, but also they provide humidity that helps to control the temperature, and it's a very, very effective way of combating, in a way making cities more resilient towards the changes that are coming over the next years. And actually, to tell you a little bit about that, we prepared a demo together with the Google team, Google Earth Engine and Google Maps team, to actually talk about this. So I want to show you live. It's actually a live website that you can go to. If you go to CSO.carto.com, you can see it. But I have it already here preloaded. Yeah, it's working fine. Right. And this is an analysis that we did together, as I said, with Google in Prague, in the Czech Republic. So the idea was to actually just look at, the impact, why it's vegetation important for the city. Like I said, we talk about environmental benefits, like the economic benefits and social benefits. So we did this story map, essentially talking about that. What you're looking at here is a map of, which is a full interactive map that I can move, and what you're looking at is the temperatures. So you can see that, like as I drag here the slider, where is, the temperatures in different parts of the city on average in summer, and you can see that, in some areas it can get to up to 36 degrees, which if you look at, the Reno, obviously water areas are, the ones that, get less temperature, but, then the most obvious are the green areas, parks, right? So parks and trees really are a very, very effective way of reducing temperatures in the city. You can see it in here. So with that in consideration, what we looked was doing an analysis of the potential of actually which areas in the city of Prague could be more interesting to actually plant trees to regulate temperature. And the first thing that we look at is just by looking at a distance to parks. So what you're looking here is just obviously the areas, are more in the center of the city, they're just farther to trees. Prague is a pretty, has a lot of parks, but, there's certain areas that, suffer that. So if you look at it and you combine it, what we created is what we call a composite index that provides you with, that mixes information around how many people live there, what are the temperatures that they're suffering, how far they are from trees, and considering around 9 different variables, create a score index that, represents what is the potential of, a particular area for planting trees. So in this case here, in this area, a tree is a very high priority based on that index. So it's a densely populated urban area with notable youth and senior citizens. So, looking at this whole perspective, right? And that should give you an idea about, what is the places that, where you should act if you working on this topic, right? So, yeah, so that's for the demo. Now, a few things that you probably have catch up. You see a lot of 3D support. So we actually quite excited to be having announced a couple of weeks ago, finally 3D support on CARTO with these Google Maps 3D photorealistic tiles. I think they look gorgeous, I think, as you can see. The other thing that you've seen that it's in this demo that we've done is using raster. Raster directly serving from the data warehouse in this case, right, from BigQuery. This type of visualizations, we're seeing more and more the world of vector and raster coming together, and you can see it on this on our raster support that we have already in the product. And finally, this composite score index. So the way that we've make this type of index is by adding in our analytics toolbox a set of capabilities to calculate these indexes in an efficient way. So I'm going to actually tell you a little bit about it, but those are 3 things that we were highlighting from our technology stack. Now, how do you do this? Is you actually, like I said, you look at different layers of information, right? Like land surface temperature, NO2 concentration. You look at mitigation potential, like exposure, like what are the places where people live, and the vulnerability, who lives there, and so on. And taking all these things into considerations, you create the index, you weight it by different weights, and you end up with an index that goes from 0 to 1, just telling you, the planting priority score. You say, that's how we actually do it. But one thing that you've maybe noticed is that we also have these labels. We actually, when we hover over a building, we were telling you, in plain English, this is a densely populated urban area with notable youth and senior citizens. So a full description explaining the situation in that particular place. Now the question is how do we make 5,000 labels, right? And that's the exciting part. Well, AI to the rescue. So, and that is what I'm going to say 100 times AI. But, unless you live in, somewhere very remote, you've probably been, hearing a lot around GPT and all the large language models that have been coming up, right? And they're really revolutionizing a lot of different sectors. So we've been actually very, I've been having a lot of fun, and some teams, some colleagues on the team, looking at how to apply it to geospatial. And a lot of the things that I'm going to be showing you, you can almost put into a new skill that probably as an industry we're going to have to start making, which is geospatial prompt engineering. How do we use AI to solve geospatial problems, right? And it's a great opportunity. So I just want to show you a little bit, how we did that and a few other use cases. Now, Large language models is not a new thing. They've been coming a long way. I mean, like GPT-4, PaLM-2, are just like the most recent and more notable models, but there's many others that are coming up. And also not only just on generative text. I mean, there's also like in image detection that I will not be covering today, but there's a whole revolution going on, obviously, on this space, as you're very aware. Now, how did we make these labels? This is actually what prompt engineering, geospatial prompt engineering, if you want to say, actually does. So you write a prompt where, in this case, I'm telling the model, like, giving a set of parameters, I'm telling them, this is my model. I'm going to make an index with temperature and all concentration, all the layers, and I'm going to give you this information from values from 1 to 0. These are my weights for my index, for my score index, right? And from now on, I'm going to start giving you new values, and I want you to explain me what is the result of the score index. So if I give it, in a particular location, then the score index is 0.62. The location is a place with high temperatures and so on. That's how you generate them. So you create the prompt that tells them, like, from now on, I explained you the model, and now I want you to explain me back the models for specific values. And that kind of like label creation is, from my point of view, one of the most exciting use cases that we can think of for generative AI now. So, so that's technically how it works internally. This is a different kind of like index, but I really love the text. I mean, like, look at this. This location boasts excellent air quality, high house prices, and a low crime rate. Not going to read it all, but however, it has limited amenities, poor school quality. Like this type of text, this type of, explanation of a model, it's much better probably than I can do myself in a presentation to someone. So if you think about, like the possibilities for explanation of the complex analysis that we do, I think this is an incredible opportunity. So I'm very excited about this, very, very excited. Now, a lot of these things are already, these things are already available. You can generate text using these models already in SQL, like BigQuery has it, BigQuery and the whole Google Cloud Platform has it, but also all the other data warehouses to connection to the different ChatGPT or GPT-4 APIs, the OpenAI APIs. You can use it in SQL, like I said. You can also use it in Python, most of it, or you can use it directly through APIs, JavaScript, and so on. But one of my favorites is actually using CARTO workflows. So one of the things that we've done over the last month is integrating these LLMs, these models, into the interface so that you can use it in your analysis, just drag and drop it. So you see now we have a new category called generative AI, and we've integrated the APIs from OpenAI and the ones from Google that just recently boosted their models to PaLM-2, and it's coming to a pretty exciting competition going on with a lot of innovation coming up. So that's how Kala looks like. But let me actually explain you this one in particular. It's a simplification. The whole analysis for Prague is more complex, but I took just like the basics. So the way that you do an analysis or an index and labels like this is you first calculate the score index. This is using the new functions that I told you about, like weighted indexes and all these things. I'm not going to go through it. This is actually more complicated probably than this. But you just, in a way, calculate what is the value of the index and the parameters for each of the cells in the grid that you are operating with for the entire Prague. Then in our case, we actually associate it to the buildings because we wanted to provide information per building, not per cell on a grid, right? So that's what we do in second. Now, that's where it gets really excited. Now, for every cell, or in this case, for every building, we call this generate text function, this generate text component. That it says like that set of parameters that I know now that are for that particular building, I'm passing it through the generative AI, and it's giving me back the text. And that is then I'm putting it together into the original data set and creating a tile set just to visualize the data on the map, and I'm just, in my case, just alerting in Slack so that I know that it's finished. So, I don't know about you, but I found that just mind-blowing. It wasn't that much of a work to integrate a lot of these things into an interface, and the level of sophistication that you can get on your analysis, it is unbelievable. So I was incredibly excited about this. So that's just one use case. I look at other use cases where a generative AI makes sense. I don't know how many of you have been using OpenStreetMap to gather data, but if you haven't, OpenStreetMap is obviously one of the best data sources to actually look for POIs, obviously roads, buildings, and so on. And if you look at the data model on OSM and the database itself, it looks pretty simple, It's because it's a schema-less type of like data structure, right? Everything is organized as nodes, relations, and ways, and with tags. And that's where it gets complicated. There's more than 90,000 tags on 3 billion objects that are managed in OpenStreetMap. So if you've ever found yourself writing SQL to try to gather data from OpenStreetMap, well, that gets challenging. So that's another great place to use these models. They're like amazing at writing, like code too. So we use it, like in this case, for we train with the model by actually explaining them the OpenStreetMap model. We can tell them, how it is structured. It knows already quite a bit. Once you've done that part of the conversation, then you can start asking questions as simple as, give me all healthcare facilities in south of Spain. Sounds very simple, but healthcare facilities in Spain, it has to go and understand that there's a healthcare tag in OpenStreetMap. It has to use the asterisk because it wants to all the tags with the value of healthcare, any value but with the tag of healthcare, and even that starts south of Spain and creates a bounding box for the south of Spain. So that's the SQL, and you just gotta run it, and it just compiles and it runs. So I don't know if you've seen. Actually, let me go back. This is the SQL that it generates, and it looks simple, but there's this nest thing, because you have to call a nest the tags to be able to access them. Writing a SQL like this, I hate it. Honestly, it is one of those really painful things that you try back and forth until you get right, and of course you can get it done. But having like a system like this make it for you is unbelievable. So you can actually pack it, this is actually the result of the query, and you can pack it in even in a function to say query OSM, and all I'm saying is give me healthcare facilities in the south of Spain. Now, on top of this string, I'm attaching the rest of the prompt, where I'm saying hey, you are an AI expert, writing SQL based on OpenStreetMap, blah, 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 and I'm gonna make a question that I want you to return me SQL that answers this. And then I place the SQL, the text, and boom. That's, again, pretty incredible. Third one that I have, finding data sets relevant to your analysis. I'm sure, I'm just putting here 50% of the time, but I'm sure sometimes it's even more. How much time do we spend just trying to find data? It's I would say it's sometimes it's 80 or 90% of the time, just finding what data sets are available, what ideas, what else could I use to, to analyze this phenomenon, etc. And how do you do it? You go to Google, you go to the data marketplaces, like CARTO, but you also like a Snowflake marketplace, like AWS marketplace. You just try to find data wherever you can that it might be relevant to your topic. And normally the way that you actually search is by looking for matches on your query. So if you're looking for fires, you look for fires, right? So you look for words that can actually match your search. And if you're lucky, and say, well, you might only spend 50% of the time. You might spend more. But this is another great place to use AI. So if you use this as your personalized expert suggesting data sets. So in this case, I'm asking, what data sets would you recommend to detect wildfires in California? And the results are pretty amazing. Already from a call, an expert that can say, you might want to look at, the incidents, you might look at the fire weather conditions. It's pretty good as a start. Tell me, Ron, this is a good answer. But what it actually really then becomes mind-blowing is when you start fine-tuning it with existing data sources that that are curated. So in this case, what we do is we fine-tune the model using CARTO Data Observatory. We tell, the LLM, hey, there's Data Observatory, and we create the so-called an embedding. We add more information to the model so that it knows what data sets are available in a catalog, what variables are inside the catalog, what is all the metadata. You essentially in a way, ingest the metadata to the model because the model wasn't trained on that particular data set. And when you do that, the response are much, much better. So in this case here, I'm having the same prompt in a non-trained or non-fine-tuned model. In this case, the question is I'm trying to find the residents and the daily mobility patterns of customers affect the sales of my restaurants. Variables in Barcelona. And you see, gives you the things that you will expect, similar again. But if you look at the right, now that it's been trained and there's an embedding, it gives you, a specific data sets that you can actually look. And the most important thing about it is I'm not searching for mobility data. I'm telling them what I want to do, and then it suggests me based on that. That's a very, very different change on the way that you look for data. So For me, this kind of like concept of embeddings and like adding metadata from the catalogs into the systems are going to be a fundamental way probably to that also there's a lot of data providers here that we have to think about how we provide data to users, because this is likely the way that we're going to be looking data in the future. Oh, I forgot. Of course, if I do the embeddings, I can provide proper URLs. One of the things that if you've tried, like any of these GPT-4 or GPT-3s or like any BART, any models, sometimes it invents the URLs. You tell them, can you give me a list of URLs? And they just make them up. So, but in this case, in embeddings, you can actually control it. So you actually get a specific, like URLs that they work and that they mean what you are trying to give them. So for me, that's also a pretty important bit. The last one that I have is a more kind of like putting all the pieces together. And it's something that is happening as an entire industry. It's not only related to geo, but it's this concept like AI is going to become, or it's becoming the new UI, right? It's how AI can fundamentally change the way that we use software. And this will modify, like not only how we do searches and how we write documents and write emails and so on, but also how we do geospatial analysis, right? So in here, I'm actually like giving you an example of something, one of the prototypes we built. So where we essentially kind of like saying, show me all the Starbucks in California. What is this doing? It's a prompt engineering, like I was showing you before, using the embeddings from the CARTO Data Observatory, so it knows the structure of a catalog. It knows, then it generates a SQL, and then it sends that SQL to CARTO to actually display it on a map, right? So now the interface that the user gets is just it's a conversation with the GIS system with the information, right? So show me all the Starbucks, and then show me all its competitors, right? And then show me like areas where there's more competition versus areas where there's more, and it goes on and on and on. And the most amazing thing around it is that, like you think about it, SQL again is at the center of it, because SQL is the language that, those prompts get transformed, because then is what the APIs and the computer and the information system understands. So because these large language models speaks many languages, and SQL is one of them, you use it as the way to connect to the products. So this is obviously, this is a start, but this is kind of like a map GPT kind of like idea, right? I mean, like you can think of like many solutions and many use cases might want to be better delivered in a conversational style instead of, like providing the information to the user and letting them drill down with widgets and so on. So it's more, give me, like an LLM that is a model that is already prepared, like with the right prompt engineering, so that I can actually kind of like make questions to it and then click on the map and say, and what about this place? And what about this other place? Like think about that. That's likely the evolution of a lot of these type of interfaces. And that I think is also like pretty big thing. Now, where is all this going? I mean, who knows? Reality. I mean, like with the advances that are going on these days on artificial intelligence, it really feels like every day there's new use cases that are coming up. And if something I will ask you, or I would recommend you to stay up to date, because like there's always new things coming up, and like I think we're going to see if only in the first half of the year we've seen so much innovation going on, I just can't wait to see what the other second half of the year is going to be. So there's a ton going on, but there is 3 things that we've highlighted here that I'm pretty confident that are definitely going to have an impact on our industry. So the first one is, you've seen it, is this concept of copilots. Like more and more products, will have, like data cleaning, discovery processes, query assistant, like it's going to get, like more into kind of like similar to developers, that now they use copiloting for writing code. The same is going to happen on spatial analysis. We're going to see more and more assistance as we work with software to be more productive and to actually do better. The second one, we talk about it too, is the AI is the new UI. So if you are thinking about if you're a developer and you're building a solution for a customer, you might want to consider if you can change the way you're going to present your information as a prompt, as a conversation to the final user, instead of just as a dashboard. So that's also a pretty important part. And the last thing, that we definitely, I can see for sure, is, is this work that we're going to have to do on optimizing the models with data catalogs. So this concept of creating embeddings to add more information to the models around, what spatial data is valuable and what is the metadata for it, so that it can suggest better things when we use it on all the other pieces. So those three things, I'm pretty sure it's going to happen. I'm sure there's going to be many more things that we're not even aware yet, but I think that's a fair assumption. Now, all of that, obviously, and this is where we got to call it be responsible AI. I mean, who knows what's going to happen? We all have to behave very responsible using AI. So I did the most obvious thing that you have to do to be responsible, which is ask a model, what is the best map projection, right? And it says it's the Mercator projection. So I don't know. These are, like models at the end of the day. So take it as you want. You might agree, you might disagree, but like they have opinions, and they also have like very strong cartographic opinions. So take it, with a little bit of grain of salt. Thank you very much.